Hello everyone, we're the project Training New Friends. A quick overview: in video games, the player is commonly given a companion that helps them throughout the game, and that these AIs are usually handcrafted and that it takes a lot of work on the hands of engineers. So our motivation behind this project is that we observe that personalized gaming experiences are something that the gaming industry wants and invests in, and can we personalize a companion using RL that makes the player feel like it has a better teammate. So a real quick overview of the environment. We're using Unity ML agents and specifically the Sockers 2's environment. And the biggest point here is that our agents see through these red LiDAR sensors shown on the right. It does all the visual inference for them, and it doesn't need to figure anything out. And so a quick overview of our approach is that stage one, we just train the agents using PPO and self-play. Specifically, we train two different models simultaneously, and this is what Unity gives us out of the box. Stage two, we train an imitation learner via Gale and behavior cloning on an expert demonstration provided by us. And then stage three, we fine-tune the companion agent from stage one in order to play better with the human by training with the imitation agent. So stage one can be shown through this video. On the left, you get the behaviors that are trained through just Unity's base implementation. In the middle is the generic character showing very offensive behavior, and then what we call the companion has a very defensive strategy that barely scores. So stage two was to train an agent through Gale and behavior cloning. The biggest problem that we faced here is that the demonstrations when recorded, they take as input the LiDAR sensors, but when the human is playing the game, they obviously make decisions based on their visual input. And we didn't realize this right away, and we didn't see that the imitation agent was training properly, and we eventually figured out this input space problem. So the fix for this was to just add LSTM memory, which you can do within Unity, and this seems to bridge the gap between what the player saw and what the agent see. And so here on the left is our expert, me playing the game, kind of bad, but is what it is. In the middle is our imitation agent, and clearly has picked up on the side-by-side movements and is able to score and kick the ball and whatnot. And on the right is the imitation agent just by itself, displaying its behavior. Finally, stage three, fine-tuning our companion agent from stage one. We do this by just modifying the reward function. Normally it would get 1 point if its team scored, but now we introduce the additional reward that if the teammate scores, it gets 2 points, which is more than it could ever accomplish on its own. And just showing a contrasting behavior between the default companion and the trained one. Right now, there really is no difference. Both companions will not try to steal the ball away from the human player. It's something that we observed the generic agent would try to score regardless of whether or not the human was trying to score. But then a big difference between the default and the trained companion is that the trained companion, when it sees that there's no human able to score, will try to score. So we think that this shows that the companion agent, after this fine-tuning, prioritizes human scoring, but will score itself if it sees that that's the only option. Final demonstration, this is me playing with the trained companion agent against two generic bots. At this point, the companion agent saw that I was terrible and then decided to score as the only option for getting a reward. We did conduct an evaluation of this, but since we were the developers and also the test subjects, we're a little skeptical of the results. And in conclusion, we were able to confirm training agents the way that Unity says that they can be trained. We trained this imitation agent, even though we required some LSTM memory within the model. And then finally, we were able to fine-tune this companion agent, which displays some team-oriented behavior. Thank you. Everyone take care.